So since we talked in March, we now are in a position to actually work with the virus. We've gotten the virus in from Public Health England. We have established all of our risk assessments and all of our code of practice in terms of working with the virus in biosafety level 3 conditions. And therefore we're ready to go. And we have been working now with the virus, the basic virology, for the last 2 or 3 weeks, getting our protocols up and running, how the virus interacts with cells, what kind of damage it does to cells, so that we will be able to assess the efficacy of the drugs that we're going to be looking at later on once we have these protocols established. So yes, we assembled the team. There's 5 individuals that are working on it. These are all senior postdoctoral fellows, all of them highly trained, experts in their own domain, and all complementary to various parts of what we want to do for the overall project.
So given how transmissible this virus is and how sick it can make people, the virologists here in Queen's really began work on this virus a couple of months ago, and we're really keen to sort of understand this virus better, so we can develop better vaccines, better drugs, and better diagnostics as well. And what all this comes down to is we really have to work with the virus and grow lots of this virus up in the lab. However, given how transmissible it is and how dangerous it is, we have to take super precautions so that we don't infect ourselves, and then we go on to infect the family, and we don't infect the community. So to do that, we work with it in a special lab called a biological safety lab, and it's level 3. And this whole lab's secure, so there's secured access into the floor, secured access into the suite. This suite is under negative pressure, so nothing's going to come out. The air is all blown in. And when we work with the virus, it's all under these special hoods, so the viruses are sucked away and taken up by the filters. And then, of course, all of our waste that we generate is all inactivated by chemicals and inactivated physically by heat, so nothing ever escapes out.
So generally speaking, as you will have seen from the folks that are working in the BSL3, the Biosafety Level 3 laboratory, they have full personal protective equipment on from head to toe, including special filter masks that they have to wear, and Tyvek suits from head to toe as well, and they've double gloved. So those that are working in the lab tend to work for about periods of about 2 hours to 3 hours at a go, because otherwise it becomes too difficult.
So we grow these viruses in monkey cells in the lab. So we grow the monkey cells in a dish, and over the next couple of days, those virus particles will infect those monkey cells, replicate, make new virus particles, and over the couple of days, every cell will be infected, and they'll spit out millions of little virus particles that we can then harvest and purify and then use for our experiments. So viruses are quite hard to visualize. They're usually invisible to the naked eye unless they're under powerful microscopes. So what we do is we can really visualize the effects of the virus by looking at how they kill the cells. So when we grow SARS-CoV-2, the virus that causes COVID-19, in our monkey cells, not only does it infect and replicate in those cells, it actually makes those cells very, very sick, and those cells will eventually die. And then when we kill them, we can then inactivate the virus and activate all those cells that have virus in them, and then stain them for living cells. So in this case, you can see that the cells are purple. The purple cells are the healthy cells, and where you see white, they're the cells that have died. So this virus has got into those cells, and over 3 days it's infected, replicated, and killed those cells. And we like to think about, imagine if it's not just in a monkey cell in a dish, but imagine if that happens in your lungs. So the virus is infecting the cells in your lungs, replicating in them, spreading around your lungs, and ultimately killing those cells. So we really want to, the whole goal of our work here is to stop the virus infecting our cells in our lungs and from killing those cells.
The goal is, as I say, is to take FDA-approved drugs and determine from those drugs if any of them have the capacity to kill the virus, so they neutralize the virus, or any of them have the capacity to block the inflammatory response that causes most of the disease associated with COVID-19. So we would hope within the 12 months of the project that we will have identified some drug candidates that are what we call antiviral, and some drug candidates that will have potential as anti-inflammatory molecules to treat the COVID-19 disease.